Hi everybody, welcome to my YouTube channel Dr.Sreenivas Medical Concepts and my FB page Dr.Sreenivas Concepts. This is Dr. Sreenivas, neurologist from Andhra Pradesh, India. I'm also the medical author of the book Focused Neurology. Today we are going to talk about a very fascinating topic, the neuroplasticity. And I'm going to talk about two important fascinating points to start with in neuroplasticity, and then we'll go about. But first, what is neuroplasticity? Neuroplasticity is neuroplasticity. Neuro means nervous system, plasticity means plasters, or they are moldable. So neuroplasticity means nervous system which can be moldable, which can be changed according to the environmental stimulus or any other stimulus, a changing pattern. But before I go into the details of neuroplasticity, I want to talk about two fascinating points about neuroplasticity. One, as we are born and we are getting older, the synapse formations, especially the number, starts increasing at a great speed. In fact, at 2 years of age, we are going to have the highest number of synapses. So when you have the highest number of synapses, you can have the highest potential of learning. But once you start reaching the age of 16, from 2 to 16 years, the synaptic connections starts getting removed. This is known as pruning, as the tree sheds off its leaves. So what is pruning? The synaptic elimination that occurs in the developing brain that is shedding unnecessary connections. So pruning is a state of synaptic elimination that is occurring in a developing brain that is shedding unnecessary connections. So at the 2 years of age, you have the maximum number of synaptic connections. It indirectly implies that the child can learn to its maximum potential from 2 years. But as the child gets older and starts reaching 16 years, there is shedding of the synaptic connections known as pruning, and the learning capacity comes down. From 16 years till the mid-20s or late 20s, it still starts shedding more and more synaptic connections, and then it stabilizes at that particular age. Further, beyond late 20s, it is almost stabilized, and therefore the amount of learning starts decreasing. So the maximum potential is at the age of 2 years, and it can go up to 16 years. So we should capitalize on this point and give the maximum possible education to children from the age of 2 years. The second fascinating point I want to talk about is the principles of neuroplasticity. There are two important principles of neuroplasticity. One, neurons that fire together wire together. Neurons that fire together wire together. And second, if you don't use it, you lose it. So the two principles on which the neuroplasticity is based is: one, the neurons which fire together, they wire together. And neurons, if you don't use it, you lose it. I can give you an example of the first principle and the second principle. The first principle is that neurons fire together which wire together. So neurons that fire together will wire together. The example for this is a person trying to throw the ball in the basket as a game. So what happens? Initially he finds it difficult to throw the ball in the basket. So it may overshoot or undershoot, or it may go elsewhere. But slowly, as he starts practicing, the myelination, the fiber starts forming between the exact pathway of throwing. For example, flexion of the upper limbs, extension of the lower limbs, and the exact pathway gets formed. This gets reinforced with the process of myelination. So you remember I said pruning. Pruning is removal of unnecessary synapses. Here it's a reinforcement of the exact pathway wherein myelination occurs. So the exact pathway starts forming, flexors of the upper limb, extensors of the lower limb, and the coordination between the vision as well as the distal muscles. So these fibers, they start firing together and they wire together. So neurons that fire together, wire together. So these neurons fire together and therefore they start wiring together and myelination starts forming and a perfect path starts forming, and at a later point of time it becomes almost a reflex action. He takes a ball, throws it, and it exactly falls into the basket. So fantastic principle. So the first principle is that the neurons that fire together wire together. The second example is, if you don't use it, you lose it. The second principle of neuroplasticity is that if you don't use it, you lose it. Example, again we can take the child. Why the child, it takes so much of time to learn to walk, learn to talk. In fact, the children takes about 2 years to walk and 3 years to talk. When you compare this with a turtle, a lower species animal, it almost walks, it almost swims in the water also. In fact, by the time this child has grown from birth to 2 to 3 years of age, the turtle would have swum a lot of kilometers. Why the turtle, the milestones are very quick and they start learning in a very quick fashion, whereas why human beings take so much of time to learn? The reason which is speculated is that human beings are designed by nature to acquire all these complex activities, multiple languages. The turtle cannot speak. The turtle cannot do gymnastics. The turtle does not have a thinking process. Whereas human beings, not just one language, they are designed to acquire many languages, multilinguistic. The child again is designed at a later point of time to do gymnastics in all kinds of permutations and combinations. The thinking process. So the brain of a human being is designed to acquire all the complicated stuff. And therefore it has got a lot of neurotic synapses in anticipation, and they start developing slowly to acquire all these complicated stuff. And therefore it takes a long time for a human being to evolve and develop all these complicated activities. It is not as straightforward as animals. Animals are simple, but human beings have got a highly complicated and sophisticated activities to be learned. And therefore, human beings take a longer time to acquire these complex activities in anticipation. And therefore, the human beings take a longer time. The milestone, 2 years, 3 years, 2 years they start walking, 3 years they start talking, whereas turtles can do it quickly after birth. The principle which actually I wanted to emphasize is that if you don't use it, you lose it. As I said, the human beings are born in anticipation of acquiring multiple languages. Therefore, when they've done a study in persons who are multilinguistics, who know a lot of languages, their angular gyrus, that is the dominant angular gyrus, the gray matter is well developed as compared to human beings who know only single language. So they start using more. You use it, you gain it. If you don't use it, you lose it. That is the principle. The second example I want to quote is that the London taxi drivers, they've done a study. They found that the taxi drivers, they need to use a lot of spatial orientation. They have to go in all kinds of directions to reach a particular place. So the more they start using or trying to use all these spatial orientation, the directions, the hippocampus, which is the GBS of the human being, the right hippocampus, especially for spatial orientation, is well developed in taxi drivers. So they started using more, so it's developed more. So you use it, you have it. If you don't use it, you lose it. So these are the two fundamental principles on which the neuroplasticity is based. The first is that neurons that fire together, wire together. Example, a person throwing a ball in the basket. Second is that if you don't use it, you lose it. If you don't use your reading or writing centers well, the angular gyrus is not well developed, the spatial orientation, the right hippocampus will not develop. But if you start using it, you have it well developed. That is the right hippocampus in the taxi drivers and the left angular gyrus in persons who are linguistics and who are good educationalists, academicians. So these are the two fundamental principles on which the neuroplasticity is based. Let's see the details of the neuroplasticity. But what exactly is neuroplasticity? The neuroplasticity is the brain's ability to reorganize itself by forming new neuronal connecting network throughout life in response to the new situation or the change in environment. So it is the ability to form new connections, reorganize itself is neuroplasticity. The plasticity or this reorganization, we see it in skin. Someone cuts the skin, if it is close by, it heals on its own. Or the skin is cut to a depth. We just suture it, but the skin heals on its own. The ends of the skin, they join on its own. The plasticity is there. Likewise, if you have a fracture, a bone gets fractured, all you need to is to give rest. The bone starts growing on its own and the fracture gets healed. The liver can get regenerated. So there is plasticity in other organs, but does the plasticity exist in human beings, in human brain? We see plasticity in olfactory bulb, we see plasticity in hippocampus, but what about the other organs of the brain? Do they have plasticity or not? To give an example, there was a Chinese woman, an adult woman. She read well at a later point of time in her mid-20s. She got married. She had children also. She was leading a normal life. No one would suspect that she's got a disease. She was leading a normal life. But slowly she started experiencing ataxia, vertigo. And then when a doctor examined and took an MRI scan, he found completely absent cerebellum. Cerebellum was totally absent. So how do you explain this? Despite the cerebellum being absent, she was able to lead a normal life till her 20s. After that only she started developing signs. That means other areas, cortical areas can take over this cerebellar function. This is neuronal plasticity. Therefore, plasticity exists in the brain. Another example we can give is the phantom limb. A person's arm, upper limb is cut, amputated. What happens? You have the hand area in the brain. You have the face area in the brain. When the arm is cut, the hand area in the brain gets diminished. But slowly what happens? Reorganization, plasticity takes place. The face area starts slowly growing into the hand area in the brain. That is plasticity again. Therefore, if we touch the area which was once the hand area, but now it has become the face area, and therefore someone touches the face, they feel as if the non-existent amputated hand is experiencing pain. This is phantom pain. What does this indicate? Again, neural plasticity. Though the hand is amputated, the hand area of the brain is lost, the face area slowly starts and encroaching the hand area. That means it has started growing. Myelination has taken place. Neural plasticity is present. So neural plasticity is present in brain. These two examples illustrate that there is neural plasticity like other organs, the skin, bone and liver. So we should take advantage of this neural plasticity and start using in neurological disorders like stroke, like phantom limb. And we do take advantage and we've developed strategies to improve and benefit the person suffering from these conditions. Right. Brain is an important organ. The weight is very less, but the blood flow is about 20% of the cardiac output, glucose is about 25%, and therefore brain, according to the nature, is a very important organ, and with numerous connections. At the age of 2 years, maximum number of synaptic connections in anticipation of complex, difficult tasks it has to learn. And therefore, the blood, cardiac output and the glucose is very high for the brain as compared to its weight as compared to the other parts of the body proportionally. Right. So as I said, the basic two principles on which neuroplasticity is based is neurons that fire together, wire together. As I said, the example is throw ball. Second, if you don't use it, you lose it. Example is the inferior parietal angular gyrus seen in multilinguistics, and the right hippocampus, which you see in taxi drivers which are well developed. They started using it, so they well develop it. If they don't use it, they lose it. The neuroplasticity is associated with the learning skills. So how these neuroplasticity, the fiber regeneration, reorganization takes place and the person starts learning, the learning skills. Basically, it is because of two events. One, the myelination. As the nerves start growing, they get myelinated. So the connections, neuronal connections gets strengthened, reinforcement from one area to the other area. The neuron starts regenerating and then they start myelinating. So there is reinforcement. So one is myelination where they involve the new fiber formation. Second is pruning. As I said, the tree sheds off its leaves. Likewise, human beings sheds off the unnecessary connections, synaptic connections. So whatever synaptic connections is required is only present. The unnecessary synaptic connections are removed. Example, if I want to walk to a particular destination, first day I'll find it difficult, second day I'll have many other connections coming on, but third day there's a fine coordination, the fine network going on to that particular area, and the area where I started, well formed, it starts reinforcing. So myelination, reinforcing starts taking place, and unnecessary connections, the fiber, the direction of the fiber going to the other areas are removed, pruning. So because of this pruning, removing of unnecessary synaptic connections and reinforcing the essential synaptic connections helps in neuroplasticity. The neuroplasticity associated with the learning skills. So the types of neuroplastic changes and learning, now let's see. So how does the neuroplasticity reorganization take place? How do persons start learning skills? We can divide it into two types. One is temporary, short term. Second is the long-lasting, last term. Temporary, as the name suggests, it has to be short term. So there is no structural change, there is only functional change. So function stage, that's why it is short term. And then they forget it. So it's only functional. It's only chemical and synaptic changes. There could be a potentiation or a depression, decrease in response. How do they remember this short-term memory? It's only functional, synaptic connections, chemical. They are not structural, they are not permanent. It is because of increase in the release of the more neurotransmitters, they become more sensitive, and then they develop large presynaptic and postsynaptic areas, and the secondary messenger system is prolonged, is increased. Because of all these functional changes, I repeat, functional changes, this short-term memory takes place. But if you want to consolidate this short-term and make it from short-term to long-term memory so that it is remaining for a long time, long-lasting memory, then there should be structural changes. Short-term memory, there are only functional changes. Long-term memory, there are structural changes. So structural and new connections are the long-term memory. There could be excitation, that is long-term potentiation, or there could be a long-term depression or inhibition. So how do they acquire this information and make it long-lasting? Sprouting. So they start sprouting, the new wires, the new neurons start forming, the sprouting. and they get myelinated. Whereas if they don't want these long-term information to be formed, or they don't want this unnecessary information to be there, they start having pruning. They remove the unnecessary synaptic connections. The chemical substances for neuroexcitation is acetylcholine. The chemical substances for neuroinhibition is GABA. And for excitation to take place, there should be reinforcement. There should be axonal sprouting, large dendrites, more branches, and more synaptic connections. So basically the memory or the neuroplasticity associated with learning skills, it could be short term or long term. Short term are only functional changes, where long term are chemical changes. So what the necessary information we need to form is by myelination. What unnecessary information we want to delete is pruning. So the myelination or sprouting of new fibers, right? Now, having learned about neuroplasticity, we need to know about the types of conditioning where we could use the principles of neuroplasticity. Remember, there are two principles of neuroplasticity. One, neurons that fire together, wire together. The second is that if you don't use it, you lose it. So we'll apply these principles, the types of conditioning and the principles of neuroplasticity. One, we have the Thorndike's trial and error test. Thorndike's trial and error test. It is about the rat, latch, food and freedom. What he did is that he's a famous psychologist, Dr. Thorndike. He put a rat in a particular cage, and then he put food outside the cage and he observed it. Initially what the rat did, it tried to somehow come out, it tried to bite the bars, it tried to wander, but accidentally it touched the latch and the latch opened and it came out, and it had freedom and it took food outside also. Again he repeated the experiment by putting the rat again inside the cage. This time slowly it knew that once it touches the latch, it opens up and it can come out and have food. So as he was repeating, it immediately was coming out by opening up the latch. So with this experiments, he came to know that the rat is associated with the latch, vision, and the wiring takes place. So it started firing. The vision, the movements starts firing together and they started grouping together. So wires, the neurons that fire together, they wire together. Neurons that fire together, wire together, and therefore a pathway was formed and the rat was able to come out easily. So this is the principle on which the neuroplasticity is based. Second is the behavioral modification test. It depends upon the stimulus and response. We have two important conditioning. One is the classic conditioning and the very famous Pavlov's experiment. The second is the operant conditioning. In the first, the classic conditioning, we have the dog, bell and the food. This is the Pavlov's experimental, probably one of the famous experimental, and I believe he got the scientific award for this. What it is that he kept a dog, a bell used to ring, and then immediately after the bell, the food was served and the dog started eating. So this slowly became a conditional response, slowly became an unconditional response. The bell, food, and the dog started salivating and eating. This went on repeating, went on and on and on. After some time, the food was not kept. Even when the food was not kept, as the bell rang, the dog started salivating. Very fascinating experiment, Dr. Pavlov did it. So here it's an involuntary, and then the animal is passive. The dog is just passive. But the second experiment is operant conditioning, where the dog has to walk to get the food. The dog has to walk to get the food. It is voluntary. It has to put in effort to go. But then it gets the reward, food. And here the animal is active. So these are the two types of conditioning. One is the classic conditioning. Second is the operant conditioning. Here you can use the second principle. Use it or lose it. So the dog, the moment it sees the bell, the auditory pathway, the food, the vision, starts salivating. So this pathway was getting reinforced, and therefore it started using it more and more. It has started using it, and therefore the connections were better formed. If it had not used it, it would have lost it. So use it or lose it. If you don't use it, you lose it. Second, neurons that fire together, wire together. Two basic fundamental principles on which neuroplasticity is based. So as I said, here you have the stimulus and then the response. This is known as conditioning. These are the two types of conditioning. The stimulus and response, the area for stimulus and response, the habit formation is corpus striatum. The area in the brain where the emotions are linked with memory is amygdala. The area where we have learning and motor skill, the procedural memory, driving the car, riding a bike, swimming, is in the cerebellum. The visual memory goes to the inferior temporal cortex. Right. Having said about neuroplasticity, the principles, the applications of neuroplasticity, how can we enhance this neuroplasticity? How can we make use it in our clinical situation scenario? So what are the general ways wherein we can improve the neuroplasticity? Two ways wherein you can improve the neuroplasticity is sleep. Adequate sleep is necessary. A 7.5 to 8 hours sleep is necessary. During sleep, you are replaying the day's activities. There is a replay going in sleep of the day's activities. The sleep rejuvenates the brain neuronal circuit, and therefore the neuroplasticity starts getting enhanced with good sleep. So sleep is very important if we want to increase neuroplasticity. Second is exercise. When we exercise, there's an increase in levels of neurotropic hormones, brain-derived neurotrophic factor. So when we exercise, there's an increase in neurotropic factors, brain-derived neurotrophic factors. There is an increase in excitatory neurosubstance glutamate. So the two ways of increasing plasticity is one, good sleep, which regenerates the neuronal circuits, exercise, which increases the brain-derived neurotrophic factors and increases the excitatory substance glutamate. The specific areas where neuroplasticity has found its use are one, in the phantom limb. I made just a cursory, I made a passing statement about the phantom limb in the initial part of my lecture. Now let me tell how neuroplasticity can be used for phantom limb. Imagine a person's left hand is amputated. A person's left hand is amputated. What is done is that there is a box wherein there are two holes and a mirror in the center of the box. So the person whose left hand is amputated is asked to put the right hand into the hole. The left hand is amputated, but he still tries to go to the hole. But he cannot go because there is no limb there. But on the mirror, this right limb appears as though there is a left limb. And therefore, when he starts moving his right limb, the left limb starts moving. So the brain gets cheated. The brain thinks that there is hand moving, and therefore again there is a good sprouting of fibers, myelination of the fibers, and the hand area gets reconnected. Neuroplasticity, the reorganization takes place. So what is neuroplasticity find? Is the brain's ability to reorganizing itself by forming new neuronal connections throughout life in response to the new situation or to change in the environment. The new situation here is the amputation of the hand. So the brain reorganizes itself and new connections start forming into the hand area. The second area where we can really put in use the neuroplasticity is in stroke, wherein we use constraint-induced movement therapy. Constraint-induced movement therapy. Imagine I have left hemiplegia. So I put a lot of constraint in my right hand. I put a lot of constraint. I will not allow my right hand to be used. So I will be forced to use my left hand. So when I start using, the new connections start forming. You remember the second principle? If you don't use it, you lose it. And therefore I start using my left limb, though it is hemiplegic, the more I start using, the more connections it forms. But if I don't use it, I'll start losing it according to the second principle of neuroplasticity. So I constrain my right upper limb, I start using my left upper limb, neuroplasticity reorganization takes place. So with these two wonderful principles, neurons that fire together, wire together, if you don't use it, you lose it. Based on these two principles, neuroplasticity can be understood and can be applied to clinical scenarios. The second, very fascinating, is that the child is capable of learning to its maximum potential at 2 years of age where the number of synaptic connections are at the highest. So the maximum number of training has to be given for children starting from the age of 2 years, because after 16 years the pruning starts take place, and the synaptic connections are slowly removed. The connections are disrupted. And another important point is that why a human being starts taking so much of time to develop is that in anticipation of complex activities which has to develop. So the brain is designed to anticipate and get a mastery over these complicated skills at a later point of time, like different languages, the different positional changes like in gymnastics, all complicated stuff as compared to lower animals. So nature has designed brains so beautifully well for it to handle all the complicated and difficult situations. That is the beauty of brain. I've enjoyed giving the lecture, and I hope you have also enjoyed listening to this lecture. If you have any comments or suggestions, please post onto my YouTube channel. You can like and subscribe my YouTube channel, Dr. Sreenivas Medical Concepts, and my FB page, Dr. Sreenivas Concepts. Thank you. Bye.